It'd be hard to find another aircraft like the YF-23, which even after 30 years of neglect would be so fiercely debated and revived by hundreds of thousands of people. This aesthetically fascinating machine took to the skies for the first time on August 27, 1990. Now, everyone familiar with the history of aviation is well aware that the fate of the project was unenviable. It was closed because it lost the Advanced Tactical Fighter, or ATF, competition in April 1991. The winner's also well known to everyone. It's the YF-22, later reborn into the F-22 Raptor, the first serial fighter of the fifth generation. One of the best creations of Lockheed Martin. Now, the fifth generation fighter is to be replaced by the sixth generation of airplanes, and in this regard, once again talked about the YF-23. In this video, we're going to tell you why even after 30 years, the ideas behind this airplane are still relevant and whether it has a chance to see the sky again. The lead developer of the YF-23 was Northrop Grumman. By the ATF program tender conditions, 2 copies of the aircraft had to be built. One was to be powered by the Pratt & Whitney YF-119 engine, the other by the General Electric YF-120 engine. The first Pratt & Whitney-powered YF-23 was named Black Widow II in memory of the World War II twin-tower night fighter designed by John Northrop. The second YF-23 was named Grey Ghost. It can be conventionally said that the YF-23 was the first fifth-generation fighter in history. After all, the ancestor of the Raptor, the YF-22, saw the sky a month after the first flight of the Black Widow II. It's also noteworthy that even before the first flight of its competitor, the YF-23 flew at supersonic speed without using an afterburner, reaching a speed of 1,700 kilometers an hour or 1,055 miles per hour. Among aviation enthusiasts, there's still a heated debate raging about the advisability of abandoning the Black Widow in favor of the Lockheed YF-22. Ironically, they are much more common than the battles surrounding the Joint Strike Fighter competition, which was won by the F-35. We're not talking about the fact that the F-35 has been criticized, is being criticized, and will be criticized despite its confident victory. What's the reason? It's trivial in its own way. The Black Widow II is one of the most spectacular airplanes in history. It's much prettier than the strange, if not ugly, X-32, which, as far as we can tell, few regret except for the Boeing engineers who developed it. Much more interesting is the technical side. And here, of course, the answers will not be so simple and obvious. Let's look at them in order. Moreover, the reasons that predetermined the defeat of the YF-23 may become the reasons why this airplane may be revived. The YF-23 received an integral aerodynamic scheme, a rhomboidal mid-sloping wing with cut-off tips and V-shaped plumage. The F-22 is made on the normal aerodynamic scheme with a high-position trapezoidal in plain view wing and tail plumage, including widely spaced, tilted outward keels with rudders and all-turn stabilizers. Although both aircraft developed around stealth technology were very different from their fourth-generation predecessors, the YF-22 looked considerably more conservative compared to the truly revolutionary Black Widow, which then looked like a 21st-century fugitive. The American military is not characterized by British conservatism. However, no one likes unnecessary risk either, especially when there's a much simpler and clearer option. But now, in the question of the sixth-generation fighters, which should be even more invisible, it turned out that the scheme of YF-23 is more promising in terms of radar visibility. In plan, the airplane had contours that were formed by straight lines. As a result, the number of radar wave reflection peak directions was reduced to 4, and the radar visibility of the airplane at other angles was reduced quite significantly. The trailing and leading edges of the all-turn V-shaped tail surfaces were parallel to the wing edges in plan view. The edges of all flaps, main skin panels, including the trailing and leading edges of the armament compartments, the tail section of the fuselage, and the trailing edges of the upper nozzle flaps had a zigzag shape. The joints of fixed and movable elements of the aircraft structure were also given a specific shape to reduce the reflection of the incoming radar signal. The fuselage nacelle, which housed the cockpit and weapons compartment, was given a hexagonal cross-section for the same purpose. Engine nacelles, fuselage, and wing had a smooth interface. Same solution was applied to the Northrop B-2 Spirit and B-21 Raider stealth bombers. The latter is considered a sixth-generation bomber. Lack of thrust vector control. Here it's necessary to make a small excursion into history. As we know, the famous F-4 Phantom II, with all its advantages, could easily lose close combat to older but more maneuverable Soviet MiGs. Therefore, the U.S. Air Force was well aware of the potential consequences of the YF-23's lack of thrust vectoring engine, the elongated fuselage of the Black Widow II, because of which the airplane likes to be compared to the SR-71, does not look favorable in this sense either, especially in comparison with the firmly shot-down YF-22. Even a quick glance at the latter reveals in it a born air fighter which is perfectly suited, including for close air combat. But gradually, the concept of application of the fighter of the fifth generation, unnoticed, crept up, struck from a distance, and left finally prevailed, and already F-35 controlled thrust vector does not have. This reduces the weight and cost of the aircraft and its maintenance. Unlike the F-22, the YF-23 movable made only the upper nozzle flap. It was used to adjust the area of the nozzle cross-section, as well as for thrust reversal during landing. From the nozzles, jets flowed between the consoles of the plumage on top of the tail of the fuselage over a flat surface, which suppressed infrared radiation and additionally shielded the engines from direct observation from behind. The thrust vector control system required for the F-22 aircraft, built on the classic aerodynamic scheme, on the F-23 seemed heavy, expensive, and unnecessary excess. The scheme, with a high collapsed V-shaped plumage, not losing effectiveness at high angles of attack and low speeds, allowed the Black Widow to perform, even with stationary nozzles, intense maneuvers. It was only required to develop appropriate control laws. In addition, along the sides of the airplane from its nose to the root parts of the wing were narrow, small side swells, having a sharp outer edge. These swells served to generate vortices during maneuvering at high angles of attack to prevent uncontrollable yawing of the aircraft. The aerodynamic scheme of the YF-23 with all these tricks allowed the Black Widow at an altitude of 15,240 meters to reach a maximum speed of Mach 1.8 and a no-force cruising speed of Mach 1.6. The aircraft showed excellent maneuverability characteristics, outperforming the competition in handling and stability at supersonic and high angles of attack. The aircraft was fitted with a digital electrodynamic control system with fiber optic data transmission lines and a central control knob in the cockpit. The onboard system architecture for production aircraft was to include the most powerful onboard multiply redundant IBM-compatible computer. The computer was to take over the functions of a large number of onboard systems, including a life support system, electric remote control system, navigation system control, target detection and identification, communication system, propulsion system, weapons control, passive and active jamming system, and the like. In fact, the pilot was isolated directly from the controls. He only had to give commands to the onboard computer, which controlled the airplane at its own discretion. By the way, today this architecture was implemented on serial F-22. As the computer's element base improved, the boards and blocks in the electronic brain of the airplane would be replaced with more advanced ones. To obtain data on barometric altitude, airspeed, angle of attack, and drift, the airplane was equipped on the sides of the nose of the fuselage with multifunctional air pressure intake rods. The nose section had openings for non-protruding air pressure sensors on the bottom and sides of the nose section. Northrop Grumman developed a system capable of obtaining all necessary air parameters using non-protruding sensors, even during supersonic flight. It was envisioned that the booms would be used to test the non-protruding sensors and then removed altogether to reduce conspicuity. Pilot protection and laser weapons equipment were assumed to be used on the production aircraft. The Black Widow's target equipment was to include a high-power radar smeared along the edges of the fuselage, plumage, and wing. This would have resulted in an all-around radar range of 70 to 90 kilometers or 45 to 55 miles. However, the use of active radar in combat strongly demarcates the aircraft, so the creators of the onboard YF-23 complex relied mainly on passive sensors that picked up the radiation of enemy radars, and on tactical intelligence information that comes from the aircraft and satellites JSTARS and AWACS in real time. Thus, the fifth-generation fighter was to be one element of the information and warfare field oriented toward team play rather than solo action. That is, it fulfilled the network centricity requirements that are now being imposed on the sixth-generation fighter. The signals that came from external sources and passive sensors had to be processed by the computer, giving the pilot data in the form of a list of targets with marks of their locations. the degree of potential threat and priority according to the task, indicating the type and nationality of the aircraft. The pilot only had to select the target and launch a missile with passive infrared or active radar guidance. The aircraft could carry up to 8 AIM-9 short-range guided missiles and AIM-120 AMRAAM medium-range air-to-air missiles in different combinations, according to the mission. The missiles were housed in internal weapons bays tandemly located in the fuselage and closed by two 5-meter or 16-feet-long flaps. Before launching, the missiles had to be pushed out of the compartment using hydraulic guides, pushers, which allowed their use at any speed. As we can see, many of the technical solutions for the YF-23 are suitable for the 6th-generation fighter. Therefore, although the YF-23 project was officially closed, it was not possible to abandon it completely. The Japanese were the first to try to revive it when they wanted to create their 6th-generation FX fighter. Northrop Grumman Corporation even passed information on the YF-23 to interested Japanese developers, but then in December 2022, Japan and the UK, in collaboration with Italy, announced plans to jointly develop a 6th-generation fighter under the Global Combat Air Program project. This project combines Japan's FX program and the UK's Tempest program, but there can be no doubt that the YF-23 developments will be used in this project. As for the American projects of the 6th-generation fighter, NGAD and FA-XX, it's known that Northrop Grumman has withdrawn from the race for the contract for the development of the 6th-generation fighter under the NGAD program. Regarding the company's participation in the FA-XX program, the development of the 6th-generation fighter for the U.S. Navy, there's no clarity. But in any case, the YF-23 developments will also be used in the U.S. 6th-generation fighter, since there's an objective need for it. So the YF-23, albeit in a different incarnation, will once again take to the air. Good airplanes, like good books, do not disappear. What do you think? Will the ideas laid down in YF-23 be realized in the 6th-generation fighter or not? Share your thoughts in the comments. Thanks for watching. We'd be glad to receive your thumbs up and subscribe to our channel. See you soon.